So, let's start with the definition. Electromagnetic waves, or EM waves, are electric and magnetic fields vibrating perpendicular with each other. Additionally, the direction of propagation of EM waves is also perpendicular to the electric and magnetic fields.
Wait, that's new. You mean the electric field, magnetic field, and the direction of propagation are mutually perpendicular?
That's right. Because of this, they are also classified as transverse waves.
That I do know. In the case of transverse waves, the direction of oscillation and the direction of wave motion are perpendicular to each other.
Absolutely right. Now, can you tell me about the speed of EM waves?
Isn't that equal to the frequency times the wavelength of the wave?
Very good. That's the general formula for all the waves. But for electromagnetic waves, we need a slight modification.
I know its speed is the speed of light.
Indeed. The speed of an EM wave is equal to the speed of light in vacuum, represented by c, which has a constant value of 3 times 10 to the power of 8 meters per second.
Then the speed of the EM wave can be written as c equals frequency times wavelength.
Exactly. And here's the pith of the concept. Since the speed of EM waves is constant, that means the wavelength and frequency are inversely related.
The higher the value of the wavelength, the smaller the frequency, and vice versa.
Very good. So, with this concept, we can analyze what electromagnetic spectrum is and how wavelength and frequency vary in the electromagnetic spectrum.
That I know. The electromagnetic spectrum ranges from gamma rays to radio waves. In terms of frequency, gamma rays have the highest while radio waves have the lowest. It can be depicted like so.
Very nicely explained, Anushka. As you can see, the frequency increases from right to left, but the wavelength increases from the left to the right.
This means gamma rays have the shortest wavelength, while radio waves have the longest wavelength.
That's correct. Frequency and wavelength are the characteristics of EM waves to distinguish one spectrum from another.
By knowing the values of the frequency or the wavelength, we can distinguish its nature. But teacher, is it necessary to memorize both the frequency and wavelength of all the electromagnetic waves?
Well, not necessarily. What you can do is, if you are given the frequency of any EM waves, you can directly find its corresponding wavelength and vice versa.
Wow, that's a life-saving trick!
Yep.
Finding this helpful? We have additional learning resources to offer for Cambridge IGCSE and AS A-level subjects.
So, teacher, shall we run through all the sections of the EM spectrum starting from the top?
Sure. Let's start with the gamma rays, which have the shortest wavelength that ranges from 10 to the power of minus 16 meters to 10 to the power of minus 10 meters. So, Anushka, what about its frequency?
As you've said before, we simply take the speed of light divided by the wavelength. That is, the lower value of the frequency comes out to be 3 times 10 to the power of 18 hertz. And the upper value is 3 times 10 to the power 24 hertz.
Very good. Gamma rays are emitted from sources such as lightning, nuclear explosions, and radioactive decay.
That doesn't sound or look safe.
Yes, it is in fact hazardous. Gamma rays, being highly energetic, have huge penetrating power, and they can destroy living cells, cause cancer and genetic mutation.
Whoa.
Exactly. But on the other hand, gamma rays have a wide range of useful applications as well. It is used in cancer treatment, disinfection in industries, security scans, gamma cameras, and so on.
Wow, so gamma rays can cause cancer, but can cure it as well? That's somewhat ironic, isn't it?
Yep. All right, moving on to the X-rays, which have a lower frequency than the gamma rays.
I know X-rays. When I was 12, I broke my arm and was diagnosed with a fracture by taking an X-ray image.
See, that's one of the usefulness of X-rays. They have wavelengths ranging from 10 to the power of minus 13 meters to 10 to the power of minus 8 meters. X-rays are energetic enough to pass through the flesh but not the bones, so the images of fractured bones can be taken.
But if I recall well, they are also dangerous, right?
Of course, if one gets exposed to X-ray radiations for a long period, it may damage their cells and also cause cancer.
That's terrible. Then what happens to the hospital staff who spend a huge amount of time there?
No need to worry about that because the X-ray machines are kept in a lead-sealed room. The lead absorbs most of the radiation and prevents it from leaking and affecting the operators.
Thank goodness they are safe.
Indeed. So next, moving down the spectrum.
Hang on, teacher. I've got this. I have a special technique to remember the wavelengths around visible light.
Oh, surprise me then.
Sure. For visible light, violet light has the shortest wavelength and the highest frequency. So anything with the higher frequency than violet should be ultraviolet.
Fantastic. Ultraviolet rays have the wavelength of order 10 to the power of minus 8 meters to 4 times 10 to the power of minus 7 meters. Would you like to add more on it, Anushka?
Sure. Ultraviolet rays are very harmful to our skin on prolonged exposure and may even cause skin cancer. Additionally, the ozone layer acts as an umbrella to block these harmful ultraviolet radiations from reaching the Earth.
Very good. That's the reason why we wear sun-blocking cream while going out on sunny days. However, ultraviolet light is also used by our body to produce vitamin D, which strengthens our bones.
So, too much of a good thing is a bad thing, huh?
Looks like that. Ultraviolet light can also be used for sterilization of medical equipment as well as fluorescence. Now, moving on to the visible range. Can you briefly describe it?
Of course. It ranges from 400 to 700 nanometers and consists of 7 different colors that are visible to human eye.
Indeed. Although this region is a very narrow portion in the electromagnetic spectrum, it is the only region through which we see the world. Anushka, can you name the 7 colors?
Easy. In increasing order of wavelength, there are violet, indigo, blue, green, yellow, orange, and red.
Good. And what's beyond red?
That's infrared. As the name suggests, it is below red, which has a wavelength ranging from 7 times 10 to the power of minus 7 to 10 to the power of minus 3 meters.
Register now for free.